So this one was a pop quiz related to experimental techniques. Okay. Check your answers at the same time. What you do. The first one, a chromatogram of a single substance T is shown. Which measurements are used to find the RF value? So if you want to find the RF value, what's the formula for RF value? RF value is a distance moved by the spot from the origin divided by distance moved by the solvent from the origin. So how much spot move? So that will be 4 from the origin and divided by how much the solvent moved from origin. So that is 3. So it will be 4 divided by 3, or we need 3 and 4. So that's why D will be the right answer. Clear? Is it clear? To find the RF value, it's a distance moved by the spot from the origin divided by distance moved by the solvent from. The next one is the chromatogram obtained using 4 substances J, K, L, and M is shown. Which statement about M is correct? First one is a mixture of J and K. So if M was a mixture of J and K, like this is J, so J is present in M. K is also present in M, but there is also another spot. So there is also another unknown substance is also present in. So this statement A is not correct. Why it's not correct? Because J and K are there and still there is unknown substance, other spots. It is a pure substance, that is also wrong. Why it is wrong? Because multiple spots are there. If it was a pure substance, then it should have only one spot. Then it is a mixture of J, K, and L. J and K are there, but L is not there. You can see if L was there, then there must be a spot at this point. If L was present in M, then there must be a spot next to, like in the same line as L. Then the last option, J, K, and unknown substance is there. There is a J present, there is K present, and this is an unknown substance. We don't know what substance, but that unknown substance is also there. So D should be the right answer. Check. Okay. Is it clear?
Yes, sir.
Then in question 3, which piece of apparatus is used to measure a variable quantity of a liquid in titration? So titration means when we find the concentration or volume of unknown solution by the known one, and we want to measure for titration, we need accurate volume to measure. So here conical flask cannot be, because the main purpose of conical flask is to swell the mixture. Pipette cannot be because pipette can only measure a fixed volume. So we are left with measuring cylinder and a burette. Both can measure a variable volume, both can measure different volumes, but because in titration we want to measure accurate volume. So if you want to measure accurate, then burette is a right. So C is the right answer. In question 4, a sample of a green food coloring was separated into a components colors using a paper clip. The results are obtained. The RF value of a blue spot. Look how to here you don't have the. There are two ways. As I mentioned, there is one way estimation is there. Another way is by you can also use a ruler or the scale. What you can do, you can use your ruler or the scale and measure a distance moved by the spot and measure the distance moved by the solvent and divide them, you will get the RF value. This is one of them. There's also a direct method in which, as we know, if we have a center position, like this is a baseline and this is a solvent, so center between the baseline and solvent, what should be the RF value? The RF value will be 0.5. If any spot is above the center, the RF value will be more than 0.5. And if any value is less than below the center, then RF value will be less than 0.5. So it means that because the blue spot is lying below the center, it means it must have a RF value of less than 0.5. And the only option which is less than 0.5, that is 0.45. So it will be the right. And even C and D are totally wrong. Why C and D are totally wrong? Because we cannot have a RF value more than even a maximum value can be 1. It cannot be like spot move more than the solvent. That's why the RF value cannot be more than. In question 5, substance L melts at -7. So we have the melting point, that is -7. And it's a brown liquid at room temperature. So at room temperature, it is a liquid. Which temperature is the boiling point of pure? First, because the substance is pure, when a substance is pure, it will boil or melt at fixed temperature. It cannot have a range. So C, B and D are totally wrong. Then the boiling point must be higher than the melting point. So -77 will be lower. So it should be higher. So what is the higher temperature? 59 is the higher. So C will be the right. The chromatography is done on a mixture containing a drug. The drug has a RF value of 0.66. The diagram is not to scale. Which spot on the chromatogram represent the drug? So they mentioned the RF value of a drug is 0.66. So we have to find which one is having a value of 0.66. So you can also work out in the manner like if you draw the line at the center. So you can draw the line at the center, or you can also use the measurement. Like if I want to calculate the RF value for A, RF value for A, distance moved by the A from the origin, so that is 12, divided by distance moved by the solvent, that is 50. So 12 divided by 50, that's equal to 4 by 5, which is equal to 0.8. So it cannot be over. When we check B, RF value for B, the distance moved by B is 9.9, and distance moved by the solvent is 15. So 9.9 divided by 15, what's the answer? 0. So that's why B is the. And for C, if you want to, B is the right answer. If you want to calculate for C, so distance moved from the origin 0.66 divided by distance moved by the solvent 15. So we'll get the RF. But B is the right answer. So I guess this is the last question, 6. This was a pop quiz which was related to the separation techniques. So answer, the first one was D, second was D, the third was C, fourth was A, fifth C,